Hello, everybody. I'm Jeff with TonePath.net, and I want to talk a little bit about signal and how sound is represented by waves on our screen that go like this, and what sample rates are, a few of the things like that. So, to kick it off, we represent all of our sound waves in our computer in 2 dimensions, even though sound happens in 3 dimensions, maybe four, depending on who you talk to. Time is a dimension too, and sound happens by bouncing off of things and hitting our ears at different times. We try to represent it all by just drawing a two-dimensional wave that's going to represent increases and decreases over time of sound or air pressure changes. And those air pressure changes creates what we perceive as sound. And now on our screen, our waves are representing a change in electrical current that then gets translated into the diaphragms of our speakers coming in and out, which pushes air, changes the air pressure at certain frequencies in different ways, and we hear that as sound. So how does our computer do that? Well, our sound samples, our audio files are all composed of usually about 44,100 different pieces of data per second. Each one of those pieces of data is called a sample, and you might see that your sample rate is 44.1 kilohertz. That means 44.1 thousand times per second. 1 hertz means 1 time per second. For anything you're talking about, whether it's sound or something else, hertz means per second. And now I've pulled up Audacity here so we can zoom in to our sound, and this is just a plucking sound. That's all it is. And if you keep zooming in, you'll see we have all these little dots. And these dots are each of our samples. We have 44,100 of these dots. Sorry, actually I'm set to 48,000 hertz. We have 48,000 of these dots being read by the computer per second. In each dot, all it is a piece of data that represents how far in or out the speaker is supposed to be and at what time. And that's it. That's all our sound is composed of, is what the air pressure is at any given time. And we change that thousands of times per second. And now we use things like interfaces and sound cards to interpret the space between these dots, so we don't get our speaker moving in these jagged motions, and it does more smooth motions to interpret the space between the dots. But really the computer is telling the diaphragms of our speakers to telling with each one of these dots, all right, now at this point in time move to here, then at the next point in time move to here, at the next point in time move to here, then at the next point in time move back. And we do that so many times and so quickly that we replicate sound through our speakers, and then we can hear it, and it sounds just like real life. So all those little dots all get read all very, very quickly, and we get, for this 1 second of sound, it takes us 48,000 of those dots to get this. And you hear there was a click where I drew stuff. What happens if I take what I drew and I repeat it a bunch of times? Of a wave, and I'll copy that, paste it again. So look at that, I drew a really high-pitched sound. And then you still got the guitar around it, the guitar plucking sound. But anyway, that's an annoying sound. And we talked about what samples are. At the end of the day, at the end of the day, what you're doing in your digital audio workstation when you're working with sound and music production is you're just manipulating these little pieces of data that can be represented by dots over, a timeline. You're just moving. At the end of the day, everything you do in there is just moving different dots up and down at different points in time. And things like the compressor, if you have some dots down here and some dots up here, what you do with the compressor is you take the ones up high down to the ones down low, so they're closer to the same level, and then you use your output gain to lift it both back up, and then your dots are more equal and you achieve a different sound, but still with the same frequencies and stuff you have in there. Or with reverb, what we do is we look at one of these pieces of data and we say, okay, it's at this volume here, so now repeat that at a lower volume every so often to represent noise hitting a wall and coming back. Or with, a simple delay, your echo effect. We just take dots and, if we want an echo, we take that same pattern of dots and add them, a second later to whatever dots we have going on a second later. We put those on top of each other. We add the amplitudes of those dots, how far in or out the speaker is, and we get a new sound wave with an echo in it. And we're just really manipulating these dots. You're not going to be thinking about dots all the time, but sometimes it'll help a lot to understand what's going on with the sound. So I hope that helps you understand a little, what is this signal that's being interpreted by the computer, this thing that looks like a blue wave, or sometimes just black bars on my Ableton, these wavy lines that don't mean much. They represent changes in air pressure at the end of the day after it's done coming through your speaker, and it's comprised of many samples that happen on the scale of 44,000, 48,000, even as high as 96,000, 128,000, who knows, times per second that the computer reads, and that gives the speakers information on where the diaphragm needs to be to create air pressure changes that we're going to receive as sound. We're going to perceive and receive as sound. So thank you for tuning in and learning about samples and sample rates. Please check out tonepath.net. We're adding stuff all the time. I'm getting going on these videos. We're getting lots of great stuff going on. So thank you for checking it out. Drop your email on the website. Subscribe to this channel. And have a great day. Thanks for tuning in.